Okay, so the third problem in the homework, there's a CWAF restaurant problem. Is this an interesting one? So let's take it from there. So you have $1,000 and you have to allocate it between newspaper and radio advertising, and you have some restrictions based upon that. So I'm gonna insert a new slide. Text boxes. Let's begin. Okay, so step one is decision variables always. So we'll have, there are two types, N and R. So those are going to be my decision variable. N is the amount allocated to newspaper advertising. And R is the amount allocated to radio advertising. Okay. So it's a monthly budget of 1,000 between newspaper and radio advertising. Management decide at least 25% of the budget must be spent on each type of media, and the amount spent on newspaper advertising must be at least twice the amount spent on radio advertising. So the marketing index, they have developed an index from 0 to 100 with higher values implying higher. So they're saying that each newspaper advertising has a audience exposure value of 50, and each radio advertising spot as audio as an audience advertising exposure of 80. So how should the restaurant allocate its budget if it wants to maximize the value of total audience exposure? So let's do that. So it's 50 for each dollar spent on newspaper and 80 for each dollar spent on radio advertising. So the objective is to maximize audience exposure to the product. So to do that, you're going to say maximize. So it's 50 units. 50 is the rating for every newspaper ad, and 80 is the rating for every radio ad. So you want to maximize this exposure rating, and we're going to do that under constraints. And the constraints are that there's $1,000 to spend, so N plus R is equal to 1,000. So again, this is the equal to constraint. You could start with less than or equal to, saying that, hey, I could potentially spend less than 1,000, but because it's a maximizing, you'll end up with the 1,000. So here you have two options: less than or equal to 1,000, equal to 1,000, and fine either way. So N is greater than or equal to, so you have to spend at least 25% on each of these. So you have to spend at least 25%. So N is greater than $250, and R is also greater than $250, right? And finally, N plus R is 1,000, N is greater than 250, R is greater than 250. And finally, the interesting constraint here, it says that the money spent on newspaper must be at least twice the amount spent on radio advertising. So you want to spend more on newspaper advertising. So you're saying that amount spent on newspaper advertising must be at least twice the amount spent on radio advertising, right? So N has to be twice the amount that you spend on radio advertising, at least twice. So these are the constraints, right? Now, most of these constraints are pretty straightforward. So for example, this constraint here and this constraint, so let's say that I'm going to make N my x-axis and R as my y-axis. So this will be a vertical line, this will be a horizontal line, right? So instead of having x-axis, so anyway, so this will be a vertical line, this will be a horizontal line. Now this will be a regular line like the one we saw, but this is going to be an interesting line because so this is going to pass through the origin. So this was the other hint that I sent with the email that I sent. So let's see how you plot a line like that, right? let's take it from there. So let's look at the endpoints. So I'm not going to look at the endpoints for these two lines, but I'm going to look at the endpoints for the first and the last line. So let me calculate some of the endpoints. So the endpoints for the first line, n plus r equal to 1000. It will be when n is 0, r is 1000. And when r is 0, n will be 1000. Right? That's one thing. And the other is n. Now, so this equation I'm going to rewrite as n minus 2 times r is greater than or equal to 0. Now, you could also say r minus 2r minus n is less than or equal to 0. Either way will work. But n minus 2r is greater than or equal to 0 because I like all my variables on the left-hand side and nothing on the right-hand side. So I just move the 2r to the other side of the inequality. So that's what you have. So n minus 2r equal to 0. So if that's the case, so if I plug in n is equal to 0, r will also be equal to 0. That's because this straight line passes through the origin. So if one point has n is equal to 0 and r is equal to 0, how do I find another point? Well, we can pick any value. So let's say I pick the value n is equal to, say, 1000, right? If I plug the value n is equal to 1000 here, you'll find that r is equal to 500. So the points that you pick don't always have to be the x and the y intercepts. They can also be some random points. You can pick any 2 points and you can join the straight line and extend it and you'll be fine. So these are the endpoints for the line. So with this we can plot the graph. So let's do that. Right there. Okay, so this is 250, 250, 1000, 1000, and then everything in there. So I'm just going to say 250, 500, 750, 1000, 250, 500, 750, 1000, right? So let's plot them. The first line is n plus r is equal to 1000. So that is this line. So it's 1000 comma 0 here, 1000 0 comma 1000 here. So you can just join these 2 points right here. Okay, now interestingly, this constraint is n plus r equal to 1000, which means that the feasible region here is just the points on the line. So it's not the points here, it's not the points here, it's just the points on the line itself. So I'm going to leave that alone for the time being. Let's look at the other constraints. So the next one is n is greater than or equal to 250. So that will be, so this is the n axis, this is the r axis, just to be clear. So n is greater than or equal to 50. So we draw a vertical line and everything on this side right here. I don't know why I'm doing that. Right? Everything on this side. Now the other line is r is equal to 250. So that's right here. It's a horizontal line. And for this, again, it's a greater than or equal to constraint. So I'm going to say everything is going to go this way. Oops. Yeah, no, I'm right. Right? Everything that's such that the value of r is greater than or equal to 250, everything on this side. Now, right? So apart from that, the final constraint is n minus 2r equal to 0. So n minus 2, n is greater than or equal to 2r. But let's first plot n minus 2r. So it's 0 comma 0 and 1000 comma 500. So 0 comma 0 is here, 1000 is here, 250, 500 is right there. So that's the second point, approximately 500 here and 1000 here. Oops. Right? So this is my final line, n minus 2r is greater than or equal to 0. Now, which side of the line is it? Is it the part towards the x-axis or is it the part towards the y-axis? That we can figure out. So the constraint is n minus 2r is greater than or equal to 0, right? So I cannot pick 0 comma 0 because it is on the line. So let me pick some of the points. So let me pick a point on the y-axis. So let's say I pick 0 comma 250 here, right? Or you know what, easy to calculate 0 comma 1000. So if I plug in 0 comma 1000, I get 0 minus 1000, which will be minus 2000 is greater than or equal to 0. Minus 2000 is not greater than or equal to 0. So all the points that are towards this side, that's the wrong side. It's the point towards the x-axis that we have to consider, right? So here the feasible region now will be, let's pick that, will be these points right here. So let's see. So it has to be greater than this line. It has to be to the right of this line. It has to be above this line. It has to be on this side of the line, but it also has to be on this line. So finally, my feasible region is right here. This is my feasible region right here because it has to be on this line. N plus r is 1000. It has to be below, towards the x-axis for this line, more than 250 on r, more than 250 on n. So there you go. That is my feasible region, which again gives me two endpoints, one right there and one right there. So I'm going to call this point x and I'm going to call this point y. Let's pick these 2 points, figure out what those points are using points of intersection, and then we'll have our answer, right? So what is point x? So again, I'm going to do all of that here. So point x, that is the point of intersection of the first line n plus r is 1000 and the line n minus 2r equal to 0. That's the point of intersection of n plus r equal to 1000 and n minus 2r equal to 0. So I'm going to multiply the second equation with a minus 1. Don't try to write the 1. Multiply the whole second equation by minus and add the 2 equations together. I'm going to end up with this. The n and the n get cancelled. R minus of minus 2r, right? Minus of minus 2r is 3r. 3 times r equal to 1000. Or r is 1000 divided by 3, which is $333.33. Remember, r is the amount of money that you allocate to the radio budget, right? And similarly, so the news budget will be 666.67. So that's one option. So that's point x. So point x is 666.67 comma 333.33, right? Next, point y. So point y is again right here. So again, it's n plus r is 1000 and the horizontal line. So the horizontal line is where the value of r is fixed. So this is n plus r equal to 1000 and the value of r, it has to be 250 because r is fixed. So that's the line. the horizontal line. So this is the vertical line because the x-axis or the n-axis is fixed. This is the y-axis is fixed, that makes it a horizontal line. So here the obviously if r is 250, n is 750, and that's point y. So point y is 750 comma 250, right? Okay, so here we are saying spend 2/3 of the money on newspaper advertisement and 1/3 of the money on radio advertisement. Here we are saying spend $750 on newspaper advertisement and $250 on radio advertisement. So let's see which ends up being the better answer. So all we have to do is plug it into the objective function and find the final solution. Let's do that. So I've plugged this into the objective function. So point x, which is let me just say 2000 divided by 3 comma 1000 divided by 3. That's what we have. So this is 1000 divided by 3 and n is 2 times that, so it'll be 2000 divided by 3. So that's the value. And so if you plug that into the objective function, so there'll be 50 times 2000 divided by 3 plus 80 times 1000 divided by 3, and that will be let me put a parenthesis around it just to be safe. $60,000. So that's the final exposure value, 60,000. Okay, let me make this bigger. All right, so that's for point X. For point Y, which is 750, comma 250, be 50 times 750 plus 80 times 250, which is $57,500. Okay, so if you take point X, you will get an audience exposure rating of 60,000. If you take point Y, you get audience exposure rating of 57,500. So obviously point X is a better solution. Now in this case, obviously, it's not it. It's better for me. The optimal solution is not an integer, and that's okay, because you're looking at dollars and cents. You can calculate in dollars and cents. You're saying spend $333.33 on radio advertisement and $666.67 on newspaper advertisement. Now here we are assuming that this sort of split is possible. In many cases it's possible, in some cases it's not possible. Here we were not given that such thing is impossible, so we are going to go with that. So we're going to say that spend 2/3 of the money on newspaper advertisement and spend 1/3 of the money on radio advertisement, right? And that's the final solution. And you'll get an audience exposure rating of 60,000 units, right? Okay, that's the solution for the third problem on the homework.